So we finish our game setup, but now it is time to connect and disconnect our players using socket.io. So what does this task consist of? Well, if I open this on up, we have quite a lot to do. No, it looks like a lot, but maybe it kind of is a lot. We'll get through it though. So the very first task here is we want to remove enemies from our game. Let's see where we left off with setting things up. If I refresh our game, we have enemies coming in. And if we think about it, well, our enemies are no longer going to be just random generated computer AI. They're going to be other players that are connecting from other places in the world. And if that's the case, it doesn't really make sense to have these additional enemies unless we want that as a feature in our game. Maybe that is a feature that you want in the future, but to just focus on the bare basics of a multiplayer game, it makes sense to get rid of these in this case. Maybe I should have done this within the boilerplate, but I did not think that far ahead. So we're going to learn how to refactor this really quickly so that we get the most bare bones game possible. Not a game, but just setup. So if we look within index.js, we have a function called spawn enemies. We are no longer going to spawn enemies, so we can get rid of that entire function. That easy, but if we're calling that function, which we are, at the bottom of our page, spawn enemies on line 112 for me, we want to make sure that we're getting rid of it because that function no longer exists. So I get rid of that, and we're looking to be in good shape, but we can clean this up even further to make this a lot less confusing to look at. I really just want to focus on adding players and removing players from our game, and if that is the case, I want to get rid of everything unrelated to a player. So that means projectiles, enemies, and particles. I don't want any of that for the time being. I'm just going to get rid of it. Same thing with our score. I don't want that either. Now I need to go inside of our animation loop and look for anything I just deleted, including our particle loops, our projectile loops, and our enemies loop. We can get rid of all this. We just want to call out player.draw. So let's get rid of all these extra for loops, which were responsible for our projectiles and our enemies. Let's keep on scrolling, and I think this is the last bracket. Looks like I have one more to go. And now this is all we need to get started. Very, very simple. We have a player, we're drawing them out on the screen within an animation loop, and that's pretty much it. So let's save, refresh, and we can see this is what we're starting with. No enemies coming in because our enemies are going to be other players, but this is a great start. Allows us to go back over to our to-do list and quickly check off remove enemies. Next up, we are going to install nodemon. What is nodemon? Well, it's going to be an NPM package. And this package in specific helps us with a very specific task. Let's say I'm over within app.js. Remember, this is our backend folder. Let's say I make a change in here. For whatever reason, I want to console log out some text that says our server has loaded. So when we start our server, we know that our server has loaded. Let's say I want to see if this works immediately by saving the file. Well, I just saved it, and if I look over in our terminal where our backend code runs, you can see, yes, our server has loaded. How did this console log out when I didn't even refresh our server manually? Well, the case is because I installed nodemon. Behind the scenes, by the way, we're going to do it together. But what nodemon does is it refreshes our server automatically right here within our terminal if you make any change within your backend file. So we made that change. We saved that console log, which logs the text server loaded. Therefore, it refreshed our server and it logged out that new text. Watch what happens when I run our server with not nodemon, but just node on app.js. Yes, we are console logging out server loaded, but if I go and change this text to server did not to load, something different, doesn't really matter what. You can see we're not console logging that out because nodemon was not listening for any changes. So nodemon listens for changes and it restarts our server when needed, and it cuts out a ton of time for when we're going to be working within that backend file. It is very annoying to have to do this over and over again manually, which is why we are going to install nodemon instead of just running things with node on app.js. So how do we install nodemon in the first place? Well, we want to run npm install. We're going to install another npm package, but we're not going to install it directly within our project like we did with Express. We're going to install this as a global dependency. That means it's going to be available no matter what directory we're on within terminal. So I could go to our home directory, I could go to our downloads folder, maybe even our photos folder. Within those folders, I'll be able to run this nodemon command, and it's really useful because we might have other node projects in which we might want to run nodemon on. So to install this globally, I'll specify that with -G, and then I want to specify the package I want to install, which in our case is going to be nodemon. So npm install -G nodemon, and we're good to go. Let's hit enter. And you're going to notice we get an error. And this error right here is related to permissions. I want to make sure that I run this as a super user because sometimes your computer, like mine right here, just will not allow you to install this unless you specify you're an administrator. So we can do that by typing sudo npm install -G nodemon, and it's going to ask for your password. I'll enter mine in behind the scenes right now. And on enter, now that installed successfully. So if things installed successfully, we should have access to that new nodemon command. We can test that by running nodemon app.js, and there it goes. We're logging out that new text, server did not load. And if I change that to server did load, you'll see now we have that logged out automatically. We did not actually go over here and restart things manually. And that's exactly what we want to happen. If you install nodemon and you tried running it on app.js and you're still getting an error, just try opening up a new tab within your terminal and running nodemon over there. Sometimes the terminal needs to resource or basically refresh with all the new commands that it has. In our case, that is going to be nodemon. And if you're wondering what terminal I'm using right here, it is called Warp. I just really like the styling and the autocomplete that it has available to it, which is why I'm using this over the basic terminal or PowerShell. But that's besides the point. It's just kind of like a bonus feature compared to using just standard terminal, which is still totally viable, by the way. So with this, we can go back to to-do and check off install nodemon. That is great. But now we need to install socket.io. So socket.io is the package that's going to allow us to connect to our backend server and then broadcast events to anyone else who's connected to it. And basically what this allows us to do is track everyone's position as they move across our entire screen. Rather than just loading one singular player from a front-end file, we're going to create that player based off of backend events and make sure that anyone else who joins our game receives those backend events as well. It'll make a lot more sense as we go through it, but first we need to install the package. How would we install socket.io? Well, the same way we installed Express, not necessarily nodemon since we did that globally, but pretty much the same way we installed Express. So let's exit out of nodemon, which I did by hitting Control-C in case you're newer to that. And we can run npm install socket.io at 4.6.1. And we want to specify that we're saving this as the exact version right here because I want to make sure that this tutorial is viable for the years to come. So make sure you're specifying 4.6.1 and then hit enter. And this will install directly within our game project, which I moved over to web at multiplayer game starter-main. And it looks like that installed, and we can always double check by looking within package.json. And there is our socket.io package at version 4.6.1. Perfect. That is the very first step, and simple enough. We can check off this new checklist item. Next up, we need to create an initial connection. How is this going to work? Well, we're going to import the socket.io package. And let's say this red box right here represents my personal computer. This is the laptop I'm currently on, and you can see I am a great artist because it looks so good. So the red is my computer, and this blue computer right here is going to be the server. The server exists somewhere out there in the world. It could be somewhere in China, it could be somewhere in New York, somewhere in California. Doesn't really matter where, but it does exist somewhere out there in the world for everyone to come into and connect to our game. So this is the server somewhere in the world. This is my own personal laptop. What I'm going to do is send a request from my laptop to the server, and it's going to receive that request. And once it receives that request, it's going to send back a response. And the response is going to contain a socket.io connection. It's basically going to create a bridge in which these two can communicate back and forth with each other real time. And let's say a third computer comes in. Another user's client computer over here decides they want to connect to our game. They visit our server, which is over here somewhere in the US, And then the server says, hey, I realize you're trying to connect to me, so I'm going to create a new socket.io connection. But at the same time, I'm also going to send you all the data related to this client over here, because this client stored all of their data within my backend server. So I'm going to take that data and send it to you, but I'm also going to notify the first player over here that you joined the game. So we're basically going to be broadcasting all these events responsible for letting all these players know who joined the game, who left, and so forth. That's a really broad idea of how this works, but we want to create that initial connection right here where the red arrow goes to the server and the blue arrow goes back to the client. That is creating the initial connection, but how do we do that? Well, in this case, we are going to use the docs. I don't want to be that tutorial guy which just goes through the docs and shows you how to do stuff, but in this case, it's probably our best shot. This is also available within the GitHub repo if you'd like to just copy and paste things and skip over this, but let's go over it step by step. So I'm going to go to socket.io's website, available at socket.io. And I'm going to click Get Started, and I want to scroll down until we see this grayish section right here. So you can see we already did a little bit of this. We already installed Express, we already have an app running on Express, but we need to do a little bit more, starting with these two lines right here. So I'm going to copy these two lines, go over to app.js because this is our backend file, and paste those two lines in. So what we're doing is we're importing a package called HTTP, and we're creating a server based off it, but we're wrapping that server around our Express server. So this HTTP package comes with Node.js by default. We don't need to install anything else because we already installed Node. And it is responsible for different networking requests regarding HTTP. HTTP is a protocol responsible for sending requests across the web. And what we want to do is create an HTTP server, which allows for those requests to go back and forth from app.js. But we're wrapping it around our Express server so that we can use these nice Express functionalities, such as this routing right here, where we use app.get, specify the route, and say what we want to do in response to this request. That's only available with Express. I mean, I guess it is available within HTTP, but the way you do it is a little dirtier code-wise to write. So it's nice that we're able to use Express in tandem with HTTP. So we're creating this new HTTP server, but why are we even doing this in the first place if Express already is a server? Well, when we import socket.io, socket.io requires an HTTP server, not an Express server. And if that's the case, well, we absolutely need this HTTP server. We cannot use the Express server to create that initial connection. So that's why we're importing this right here. But if we're using the HTTP server combined with our Express server, we need to take the server const and make sure we replace app.listen with server.listen. So we're listening on the HTTP server, not directly on the Express server. That is going to be step 1. Save and refresh your game to make sure things work. It does not work for me. And if that's the case, I just need to make sure that I'm always running nodemon in app.js. So our server loaded. We can refresh, and everything looks to be just fine. So we can continue onwards. So back to getting started within socket.io. We don't need to do anything else here, but we do need to scroll down until we hit the integrating socket.io section right here. So this gives us this code snippet, and we really only need to start with these two additional lines where we require socket.io and we create a new server based off it. So let's copy those two. Right beneath where we created this new HTTP server, I'll paste those on in. So to help clarify what's going on here, I want to add a comment that says this is socket.io setup because all these are working in tandem together. But really what we're doing is we're importing this package, which we installed within package.json using npm, and we are getting the server object associated with this library. So really, we're creating a server around a server around a server. The socket.io server is right here, which we're storing within io, and then we're wrapping that around an HTTP server, which we're wrapping around an Express server. I know that's kind of complicated, but once we get past this initial setup and we just focus on this IO part, it's going to get a lot simpler. But just know, we're kind of combining 3 servers into one to get all the functionalities that we want within this game. So this is the start, but now we need to actually establish a connection between our backend and our front end. And to do that, back over in the docs, you'll notice that they also provided these 3 lines right here. So I'll copy these. And right beneath app.get, we have an io.onConnection. So basically what this is saying is, if a user on the front end tries establishing a connection with this backend, our IO const right here from socket.io is going to log out a user connected event. So anyone who visits our app is going to cause our server to log out a user has connected. But in order for this to work, we need to make sure that we're trying to establish a connection from the front end, which we're not doing at the moment. So we need to scroll on down and add in this code right here. You'll see the docs are trying to load in socket.io on the front end using this syntax right here, which you can do with node modules, but I always found this to be quite buggy, so I think it's a lot easier in this case to use the CDN that they provided. So I'll grab the CDN link, make sure that I head back to index.html, and right above all of our JavaScript that we're loading in, I'll paste in socket.io.min.js, and make sure that I change the version here to the version we're actually using on the backend, which remember, is 4.6.1. And that should still function correctly. But by importing this, it's going to allow us to create this socket variable from this IO function. So let's grab this, go back to index.js, and right beneath where we establish our canvas and so forth, I'm going to paste in that new socket. I'll make it a const instead of a variable for clean code. And now IO is available to us because we added in the CDN script tag. And since that's available to us, when we call IO, it is creating a connection to the backend server, or at least it is attempting to. So let's make sure that we save our frontend index.js and our backend app.js. And now, when I refresh our game over here, we should see a connection being logged out in our backend console. So let's refresh and go back to our terminal, and you'll see we're logging out that text. A user has connected. Perfect. That is exactly what we want. That means we successfully created a socket.io connection between the front end and the back end. And now we can begin broadcasting events to anyone who joins our app, anyone who joins our game as needed. So let's look at to do and check off create the initial connection, create a new HTTP server. We created a socket.io server based off of that HTTP server. And then we listened for a connection event, which we logged out in the console. Perfect. So now that we have a socket.io connection running, we can create our first player using socket. How would we go about doing this, and what is the smartest way? Well, I think it makes sense to show you directly within the code. So how this is going to work is our backend is going to be responsible for managing all of our players' properties. That means my players' properties, your players' properties, anyone else who joins our game. Our backend server is going to store that data. Because if you think about it, if we only load our front-end file, how are we going to get all the data associated with other players? We're only loading this on our computer, so really we only have all this available to us. If we don't have all the extra data related to other players, which we can only get from the server, well, we're kind of screwed. We don't really have a way to show where those players are, what color they are, how they're interacting with our game. So we're going to store all of our player state within our backend on app.js. And to do that, we're going to create a const called players. And it's going to be set equal to an object rather than an array, because this is going to be much more performant for adding in and deleting players. When you add in and delete players using an array, typically you have to search through the whole thing. But when we use an object like this, we can pretty much delete or add them instantaneously, which is just a little bonus to speed up our game in case it starts getting really complex. So we're going to store our players as an object. And inside of this player's object, as someone joins our game, we're going to add them in as a new object property. And that might look a little something like this, just a totally random ID to help identify that one specific player. Make sure that they are completely unique from any other player that might join in. And this player is going to have a position property associated with them. Could look like this. We have an X of 100 and a Y of 100. This means that our player is going to be placed somewhere on the top left corner of our screen right here at 100, 100. Now we can add in other properties as well, such as what color this player is. They might be yellow, while another player might be red. You kind of get the idea. But another player might join in on our game. They're going to ping app.js, which we see right here. And if they join our game, we're going to add them to this player's object. But they will have a completely new, unique ID to help identify them and differentiate them from the first player. but they might be in a different position. They might have an X of 200, a Y of 200, and then a color of red. So anytime someone joins our game, we're going to add them to this player's object, and then we're going to broadcast this player's object to everyone's front-end client. That means I'm going to get all the data related to these players. You're going to get all the data related to these players, and we're going to know exactly where they are, what color they are, and anything else that might be associated with them. Let's say a player leaves our game, then we're going to delete a player from this player's object. So let's delete the second player. And we're going to broadcast this new player's object to everyone to make sure that they know these are the new players available in our game because one of the older ones left. So hopefully that's starting to make a little more sense to you guys. But we want to make sure that we store all of our players on the back end so that we can broadcast their state to all the people on the front end. We always need to make sure that everyone is getting the same data and that someone isn't placed on a position of like 500, 500, yet no one else is able to see that because it's not stored in the back end. So that's the general idea here, is we want to populate this player's object and broadcast it to everyone on the front end accordingly. So how would we begin populating this player's object using this format right here? Well, let's keep it empty to start. And we know whenever a connection is established between the front end and the back end, well, we know a user has connected, which means this is a great location to begin populating this player's object. I'm going to say, select the player's object, and then I'm going to add in these brackets right here to help specify a property that I want to add in dynamically. So let's say I want a unique ID related to the player who just connected. I can get that through the socket argument within this callback function on connection. So the socket argument has an ID property associated with it. And it looks a little something like this right here, just a random string of characters and numbers required to help separate one player from another. But when I use things in this format using an object like players, it's going to create this property for me automatically. It's essentially the same thing as saying .socket.id, but this is referencing the property of socket.id. It's not actually creating it. If I want to create this property, I need to make sure that I use this bracket syntax instead of the dot syntax. Otherwise, it just won't work. So I'm creating a new player object with a property name of whatever the socket ID is. And I want to set this new property equal to, well, an object containing positional data, such as an X, which we'll set equal to 100 to start, and a Y set equal to 100. This means that any player who joins our game, no matter what their ID is, they are going to spawn at a position of 100, 100. And we can make sure that this is being populated correctly by console logging out our player's object right after a new user is connected. So make sure that you have app.js saved and nodemon is running in the background, and then refresh over here to create that new connection. So as long as you refresh and you have that new connection created, you should see your player's object being logged out. And inside of this, we currently have two connections on our backend. I think because nodemon reloaded it once and then I refreshed, so we added in two new players. But you can see that socket ID right here is created for us automatically. And then we have a position associated with each. That's exactly what we want to start, because then when a new user joins, we can send out these player objects to a new client and make sure that they're rendered out in their correct positions, such as an X of 100 and a Y of 100. So this is an absolutely great start. But let's make sure that we have a player rendered out based on these positional coordinates. Whenever a new player connects to our game, we want to essentially broadcast the state of every player to the client's front end. Every single client's front end, that is. To send an event to every single client's front end, we can use io.emit and then specify the event name. So the event that's currently happening right here is going to be called update players. And this is totally arbitrary, something that I named, but it makes sense. Whenever a new user has connected, we want to update everyone's players on the front end. But what do we need to update everyone's players on the front end? Well, we need our whole players object right here that contains all the new positional data on any player that just joined our game. So we want to make sure that we're sending through the players object. And just a quick note right here is, if you only want to emit an event for the player that just connected, you would call socket.emit, not io.emit. But we want to make sure that this is broadcasted to everyone. We want everyone to know that a new player has joined the game and to render the results accordingly. Therefore, we are using io.emit. So we're emitting this event. Now we want to receive it on the front end. Let's save app.js and go over to index.js to receive this event. So how would we receive this? Well, we need to use this socket constant which we created with socket.io and type on. We're going to listen for a particular event. What event do we want to listen for? Well, no other than update players. So on the event of update players, we want to call the following arrow function like so. And this is going to contain all the players data that we passed through on the back end. So if we console log out this players data, we should see this logged out in the browser now because this is our front end file, not our back end file. So let's test this out. When a new player joins, we're going to call anything inside of this connection callback. We're going to log out a user is connected. We're going to create a new player within our players object. And then we're going to emit the event update players to all the players connected to our game. Refresh, and then right click, hit inspect, go over to console, and we have an object being logged out. And we look inside of this, and here are all the players currently within our game. We have so many because I've been hitting refresh so many times behind the scenes, but you can see that we're logging out every player, their unique ID, and where they are currently placed on the screen. Right now they're just going to be placed on top of each other, but we will change their positions so that they're put in random locations and so that we don't have any overlap as we load the game for them. So how would we begin rendering these out on the front end now that we have them available to us? Well, we need to basically create a front end players object responsible for maintaining all the front end properties related to these different players. We're not just going to have a simple X and Y coordinate with our front end players. We're going to have other things associated with them, such as an update method, a draw method. Any other method that might be available to these players are going to be associated with those objects. But we can't pass those methods up to socket.io. It just doesn't understand them. I've tried, I promise. So we basically need to have a backend players object responsible for storing all the main backend player data. But we're also going to have a front end players object responsible for maintaining all the actual player objects that we use to render things out on the screen. They're still going to contain positional data from the backend, but it's important to note that they will be somewhat different because front-end objects are just different than the backend ones, at least Canvas front-end objects are. And just to quickly show you this, if I look within our classes folder and look at player.js, we have this draw method associated with our player, and we have things like our radius and color associated with them as well. These aren't things that we necessarily need on the backend, therefore we're going to create that separate players object. So let's begin by doing that. In index.js, right beneath where we're creating our initial player, I'm going to create a const of players and set it equal to an empty object. Exactly what we want. So we're going to use this players object to render out all of our players on the screen. But not just yet, because we actually need to populate this from the backend. But how do we even do that? Well, we know when a user visits our game over in app.js, what are we doing? We're emitting an event of update players. If this event is emitted, we receive that on the front end right here, and then we console log out all the players available to us from the backend. So we can use those backend players, and we might even want to rename this argument right here to backend players. We can loop through every single player within this object right here by typing for const ID in backend players. So what this is doing is it's looping over all of our backend players objects. But remember, each object is identified with a unique ID. And if that is the main property of these objects, we can grab that by specifying the ID right here as the const ID in backend players for loop. It's just a unique way to loop through object properties. But now what we can do is grab one specific backend player that we're looping over by declaring a const called backend player singular. And to grab that one particular player we're looping over, we can grab this main backend players object, use the bracket syntax, and pass through the ID right here. So we're looping over all those backend players, and we're selecting just one individual backend player by specifying the ID of that player right here, and then storing them within a const of backend player. So we're going to loop over this X amount of times, could be once, twice, depending on how many players we have in our game. But for whatever player we're looping over, we're storing that within this const right here for easy access. Now what we can do is, as we're within this for loop, we could say if we reference our front-end players object, which we just created up here, add some brackets, and type ID, and say basically, does a player on the front end have this ID of the player on the back end? If not, which we can specify by adding in a bang operator right here, Basically saying if the backend player does not exist currently on the front end, what can we do? Well, we can create a new player and store them within this player's object. How do we do that? Well, we take our player's object on the front end, remember? And then specify that we want to add in a new object with a property of this ID from the backend player. And then we're going to set this equal to a front-end player object, which we created up here on line 14 by specifying a new player from our player.js class. So I'm going to say a new player equal to this new player object which we're creating, but I need to make sure that I specify the x and y values based off of the backend player we're currently looping over. So I'm going to grab our backend player and reference their x value for x. Do the same thing for y, get our backend player and reference that player's y value right there. So now whenever a user joins our game, we're going to loop through all of our backend players, and if a player does not currently exist within the front end version of this player's object, because we're specifying to create new players right here and store them within that player's object on the front end. So let's console log out the player's front end version. Save and refresh. And it looks like I just had a mistake here, black end player. We definitely want to change that. That does not make any sense. So a little mistake right there. Change black end to back end. And then refresh, and there we go. We have some players being created on our front end, and you can see these are equal to player objects, not just equal to bare objects that we created on the back end. We actually have methods associated with these objects as well, such as the draw method available within the player class. And since these are available to us, we can now render out all the contents of this player object within our animation loop, which should get the player showing at that exact position, which we specified over in the back end when we created those new players. So I'm no longer going to console log out players, and I'm going to head inside of our animation loop right here. Instead of calling player.draw for the one singular player we created right here, now we're going to loop through our whole player's object, which we can do by using the same syntax that we used for our backend players. So I'll say for const ID in our front end player's object. Then I want to select one individual player, the one we're currently looping over, by saying const of player is equal to our player's object, and I want to grab one particular player by referencing their ID. Once I have that player selected, I can call player.draw because we know that these are player objects, and now we should see them being drawn out on the screen at a position of 100, 100. Let's refresh, and there we go. Our player is placed at a position of 100, 100, but if I were to keep refreshing, we can't see any new players joining the game because they're just being overlapped on top of each other, even if multiple ones are there. So we definitely want to be able to fix that. But for now, let's head back to To-Do and check off creating a first player using sockets. I think we successfully have fulfilled that task, so good job to you, and I suppose me for getting you through it. So what is next? Do we want to create multiple players with sockets? I suppose we are creating multiple, but we want to make sure that they're showing up in different locations to basically make sure that everything is working correctly. We can't really tell. It kind of only looks like we're creating one at the moment. So how would I randomize the positions of these players? Well, let's do a really bare bones version just to make sure that this is working. And to do that, I'm going to go to app.js. Right now, we're specifying a static value of 100 for x and 100 for y. Instead, I'm going to give ourselves about 500 pixels to choose between on both x and y. If I want a random value, I can multiply this by math.random on both axes. And now that's going to give us any value from 0 to 500. Anytime a player joins our game, we should see them rendered out at some random position based on this range. So let's save that, refresh, and you can already see players being rendered out in different positions across the screen. But why every time I refresh do we see a new player appear? When someone refreshes, that player should no longer exist in the game, but what's happening right now is we just keep creating a new player within our backend player's object. Every time someone connects, we just keep adding in that, but when a player refreshes, we never actually remove them. And that is a big problem because now we have all these excess players in our game, not really what we want to make something that actually makes sense to our players. So every time a player leaves, we want to make sure that they disconnect from our game. To do that, within our connection event listener, we can grab this socket right here and say on a disconnect. So when this specific user has disconnected, we're going to call the following callback function, And this has a reason as the argument, which means we can console log out the reason for why they disconnected. It could be something like a timeout, they disconnected on their own terms. We might want to know the reason for a particular event, so we'll console log out the reason someone has disconnected. But when someone leaves, we want to make sure that player who left is deleted from this player's object right here. And we can do that by typing delete players, and then what player do we want to delete? Well, we can get the player that just disconnected by referencing socket.id. The socket is always going to be connected to whichever player is connected to that client. So if one client disconnects, we get that socket ID and we delete them from the player's object. So say that players was full of this object right here. This is a really crappy looking object, by the way. This is one player. They disconnected. We're going to call delete players at this ID right here. We paste in ID and delete this ID from the player's object. Deleted, they are gone from the backend. That's how this works right here. So let me Control Z real quick. We do want to keep delete players, and this is going to delete them from the backend, but the player will still be rendered out on the front end unless we delete them from our front end player's object right here. We definitely want to make sure that we're doing that as well. So we delete them from the back end, and then we emit an event that deletes them from everyone's front end too. So we want to emit an event to everyone. How do we do that? We call io.emit. And what event are we going to call? No other than update players, the same exact one that we called right here, because all we're doing is updating the state on the front end based off the state from the back end. We will have to update this very shortly, but we do want to pass through as a second argument the updated players object that no longer has the player that we deleted. We want to make sure that we're passing that through, and then we go back to the front end and call this code right here inside of this update players event listener. So basically we're going to be doing the inverse of what we did right here for adding in a player. When we update our players, we're going to see, is there a player that exists on the front end that does not exist on the back end? If one exists, then we're going to delete that object from the front end so that the back end's player object matches up with the front end player's object exactly. We always want to make sure these are exact as possible. So back end players is going to have one less player, which means we want to loop through all of our front end players instead. So we're going to follow the same syntax and say for const of ID in players. And this is our front end players object, which remember might have some players that exist on the front end, but not the back end. So this might have more players inside of it than the back end players object right here. And then we're going to say if we select our back end players and we pass through the ID associated with our front end players, if one does not exist on the back end, then we want to make sure that we delete this player from the front end. So we're going to grab our players.id, basically what we're looping over, and we want to make sure that we delete this. So we're deleting the player associated with this one particular location on our front end object. This is going to make sure that our front end object matches up with the back end object pretty much perfectly. So every time we call update players, whether it be we create a new player or a player disconnects, let's console log out all of our players within our front end players object, just so we can really see what's going on here. Let's save and then refresh. And now we have one player within our front end object, and there they are. Let's refresh again. We still have one player. Refresh again. And no matter how much I refresh, well, actually, it looks like we have a second player added in. Where is that second player coming from? Even though we're removing everything using these lines of code right here, we still had a second player added in, even though I was just refreshing, and therefore a player should have been disconnected and removed from the front end and back end completely. Why are we still getting a second player in there? Well, sometimes if I refresh as fast as possible, we're going to get some players added in here, and it might take a little bit of time, but sometimes the server cannot handle the amount of requests coming through so much that it cannot call the disconnect method right here quickly enough to actually delete the players from the back end. Therefore, it's populating our front end with all these players that might have gotten through. So we need a way to time these players out. If somehow our server was not able to actually disconnect the player when they left, we should only allow that player to be in the game for about, I don't know, 5 seconds or so before we remove them completely, because they're not actually valid players. So if somehow our server allowed someone to join the game and then that person leaves immediately, we don't want them rendered out on the screen. And you might have just seen that those players were removed automatically because they were timed out. And if a connection was timed out, socket.on disconnect is called automatically for the reason of timeout. I bet you if we look over here within our terminal, we're going to have a timeout reasoning. There it is. It's saying that those users who were created basically were disconnected because of a timeout. It just took a little bit of time. So if we want those to be removed quicker, we can specify a timeout of around 5 seconds. I think the default is like 25 or 30. So if players are created on refresh, we definitely want to make sure that we have some sort of timeout in place to remove those players over time if they are not valid players. So to remove players with a quicker timeout, we can go up to where we're creating a new socket.io server. And as the second argument, we can paste in or write out this object right here. It's going to contain a ping interval option and a ping timeout option. So basically, this is going to say the front end should ping the back end about every 2 seconds. And if the back end does not receive a valid response within 5 seconds, meaning that we're pinging the back end 3 times at least, then we're going to disconnect that player altogether. So we need to make sure that a player that we create on the back end is valid. And we're testing to see if they're valid every 2 seconds. If after 5 seconds they are proven to be not valid, then we call disconnect, which deletes the player, which in return updates the front end and deletes the players over there. So this should go ahead and remove those extra players that were invalid a lot quicker. Let's save, and then go back to Chrome over here and refresh as quickly as I can to try to create that bug again. Now we have that extra player, which is invalid, and you'll see it's just removed pretty much automatically because they timed out. Let's see it again. We have another player, and after 5 seconds or so, we should see them be removed, and there we go. So removing any invalid players, but let's open up another window to see how things look over there to really make sure that our connection's working between these two. So I'm going to dual screen this, and if I refresh on the left screen, you'll see this is the player associated with this window over here. But if I refresh on the right screen, we have a new player associated with this object right here. And these two aren't going to delete because these are valid browser windows. They're not going to time out or anything because we're currently within the game. We are valid users within this. So no timeout's going to be called from socket.io. But you can pretty much see how this is working right here. We're populating our backend players object. In return, we're populating our front-end players object to everyone, including these two browsers right here. So we're saying based off the backend object, create this player, and then create this player. This window is associated with this player right here. This one's associated with this one. We'll soon be able to move these independently. But this is a great first step for creating that connection and creating players in a format that makes the most sense so that we can manage this in a really good way in the future. So I know this is a lot to take in. Hopefully you guys understood as much as you could in that. Did my best to explain it. So let's head back to to-do and check off create player with sockets, and then remove players on disconnect and timeout, which in return means we can check off this whole video of connecting and disconnecting players.